Stage 2 of functions. The domain of a function is the set of all input values, and the range of a function is the set of all output values. So just remember, like we learned in the investigation, x corresponds to domain, y corresponds to range. One of the ways I remember which is the alphabetical order of x, y is x first, y last. Domain D comes before R, so D corresponds to x and R corresponds to y. If every vertical line drawn on the graph of a relation cuts the graph exactly once, then the relation is a function. This is the vertical line test. So basically, if the function has one layer and not two layers in some places, or one layer and a dot, or anything where there are two turtles instead of one turtle in the investigation, then you know that it is a function. And we can prove this by doing a vertical line test, which is if we can cut the function every single place and only hit it once, then it's a function. And in this case, do you see that sometimes when I do a vertical line, I'm hitting it in two places? So that means it's not a function in both of these cases, right? Okay, let's look at number 1. That's called the vertical line test, by the way. Find the range of the function y equals x plus 3 when the domain is -1, 0, 1, 2. Okay, so basically, this first one is really easy to do because we can use the calculator and see the entire set, okay? So what we can do is we can put this function into the calculator, and then we can use the table. So I opened up y equals and I typed in x plus 3 because they gave us the function. And it's interesting to see the difference between the part A and part B. Part A, since it gives us individual whole numbers, the best way to see the answer is using the table, because the table shows us the exact same thing. It shows us whole number x values and shows which y value that corresponds to. So the y values that correspond to -1, 0, 1, 2 are 2, 3, 4, 5. So I'm going to put those here. 2, 3, 4, 5. Okay. And when I look at B, it gives me an interval. So like instead of giving me -1, 0, 1, 2, if it says less than or equal to like this, doesn't that also include all the decimals between -1 and 2? So how do I see that? So the best way to see that is with the graph. Okay, so let's see. So I have all the values between -1 and 2. How does that correspond in terms of y? One of the easy ways to see that is we could use the window, and why don't we cut off everything to the left of -1, everything to the right of 2? So I could put -1 in for x min, and I could put 2 for x max, and I'll graph it. And then it gives me a bunch of different y values, okay, that correspond to the values from -1 to 2. And if I want to see it with a little bit more detail, I can do zoom fit, right? Because that'll adjust the y value perfectly. Zoom fit, I think, is option 0. Yeah. Okay, so this is, one problem is I don't see where the x-axis is, and they don't label the tick mark. So let me change it now to y min of 0. Change y min to 0. Okay, 0. And now I'm going to graph it. Now I know that the bottom of the graph is 0. Now that I know that the bottom of the graph is 0, I can see that the lowest y value is -1, right? -1. And the highest y value, or the lowest x value is -1, and the lowest y value is 2. And then the highest y value is 2, 3, 4, 5. Okay? If I wanted to make sure, I could do trace -1. And that should give me the y value that corresponds to that. Yeah, 2. And then I could do trace 2, and that'll show me the y value that corresponds to 2, which is 5. So I can see that this line ranges in value from 2 through 5. So I'm going to put that down as the range. 2 is less than or equal to x is less than or it shouldn't be x, it should be y, because it's the range. 5. Okay, and then the last one is capital R, and this R is written kind of like this, and this R means all real numbers. Okay, all real numbers basically means the entire number line. If you put the entire number line into this function, what do you get out? You get the entire number line out too, because the y values are going to range from negative infinity to infinity, just like the x values range from negative infinity to infinity. So the range in this case is also all real numbers. It would be y is an element of all real numbers. I'm sorry, let me get rid of that. Y is also an element of all real numbers. Number 2, consider the function y equals negative 2x, does that say plus 3? Yeah, negative 2x plus 3, where negative 1, or x ranges from negative 1 to 3, including the values of negative 1 and 3. Okay, and why don't we type that in the calculator? So I'm going to put negative 2x plus 3. Okay, and then I'm going to first look at it from the point of view of table. Okay, and first it asks me, find each image, x equals negative 1, x equals 3. Remember, the word image means find the y value that corresponds to this x value. So the y value that corresponds to negative 1 is apparently 5, according to the table. The y value that corresponds to x equals 3 is apparently negative 3. Find the value of x when y equals 2. Well, this is kind of backwards from before, right? And there's a couple ways to do this, and I'm going to show you both ways. Both ways are a little bit more advanced than going from x to y. Okay, so the problem is, look at this. I don't have a y equals 2 here, right? Y equals 2 looks like it would be between 0 and 1x, but we're not sure, right? How can I see what is in between 0 and 1x? I can't see there. So I could do something like plus 0.1, and that would change the value I jumped by to 0.1, and then doing that, maybe I can see which value lands exactly on y equals 2. And there it is. It's x equals 0.5. So x equals 0.5 corresponds to y equals 2. Okay? Let me show you one other way to do it. You could do the graph, okay? And I want to know when y equals 2. I can't really see exactly from the graph. So what I do is I put a second function in here that is equal to the value I want to see it land on, which is 2. And then I graph that. And now I can see that this intersection point is what I'm looking for. How do we figure out intersections? We do second calc intersect. And then we hit enter 3 times if we're just doing straight lines, right? So x equals 0.5, y equals 2. So the answer, again, is x equals 0.5. So either way you do it, the answer is x equals 0.5. There are advantages and disadvantages to both methods, but know how to do both methods eventually. Okay? If you want to start with the second table method because you think that's easier, that's fine. Draw the graph of this function. Okay, so whenever you draw the graph of something, it's always better to work from the table than to work from the graph, because the graph, it's kind of hard to see what's going on in the graph sometimes. So I'm just going to go to the table, and once I go to the table, okay, second table, okay, I'm going to grab some points which I can use to graph on the grid, okay? And let me go back to jumping by ones instead. And remember, when you go back to jumping by ones, position the cursor exactly on a whole number before you do plus 1. Otherwise, you're going to have to do second table set and fix it, all right? Okay, so we're looking at the blue function. And I'm going to grab some points here. And let's see. We only want it to be valid between -1 and 3, so I'm not going to put the value for -2. I'm going to start with x equals -1. So x equals -1 corresponds to y equals 5. -1, 5. And then the next point is 0, 3. And the next point is 1, 1. And the next point is 2, -1. And I want to go up to x equals 3, so I need to go to 1 point, x equals 3, y equals -3. Okay, so there it is. Okay, alrighty, so there is the graph of the function, and I clearly indicate the endpoints because it does not go past this point, right? This function only ranges from -1 to 3, so I'm not going to make it into a line which goes on infinitely. I'm making it into a line segment which ends here and here. It ends at x equals -1, and it ends at x equals +3. Okay? And finally, hence find the range of this function. So using the graph, it's a lot easier to find the range of the function because you can just like check to see, okay, what y value does this correspond to? The endpoint corresponds to y equals 5 and y equals -3. So I can write this out as an interval by saying that y ranges from -3 to 5, and I'm including the values -3 and 5, and that's why I put less than or equal to instead of just less than. Okay? All right. Next one. Determine which of the following relations are functions. Now we can use the vertical line test. And when we do the vertical line test, basically what we're doing is we're trying to cut it vertically. And if there's any place where we cut vertically that it intersects the function twice, then it is not a function. So not a function because the vertical lines are intersecting in two different places. C is pretty tricky because it's got these little dots, right? And if you can't see the dots, I'm going to redraw them here. There's 3 dots there. Are there any places where if you draw a vertical line, you're going to cross through 2 dots? Yes. So it is not a function. And, oh, I forgot to do B. So B has these points here. Are there any points that are on top of each other? No. So this is a function. And D. D is just this horizontal line. Well, if there's only one horizontal line, no matter where you chop it, you're only going to hit it once. So it is a function. Finally, E, there is a vertical line, and it doesn't hit anything if I draw vertical lines next to it. But if I draw a vertical line on top of it, I'm hitting it an infinite number of times. So vertical lines are not functions. Okay, and I think that's it for this page. Yeah, we're already on page 3.